What is the linear equation and what is the linear equation in one variable? Now, before talking about the linear equation and the linear equation in one variable, let's quickly revise what is the difference between an algebraic expression and an algebraic equation. Here we have an algebraic expression that is x, but here we have an algebraic equation that is x is equal to 5. X expression, but x equal to 5 is an equation because this equal sign tells us that now this expression has a value and that value is 5. Same thing here, x plus y is an algebraic expression, but x plus y is equal to 3 is an algebraic equation because now this expression has a value and the value is 3. X plus y plus z is an algebraic expression, but x plus y plus z is equal to 20 is an algebraic equation because this expression has now a value that is denoted by the equal sign and the number that is 20. So here on the left hand side we have expressions, and on the right hand side we have the equations, the algebraic equations. Now just take any single one of it, and let's say that this one, x plus y plus z is equal to 20. Okay, now in this x plus y plus z we have this one is the left hand side, LHS, we write it as LHS, that is left hand side, and we have RHS, that is right hand side. Okay, so let me write it here. We have LHS, that stands for left hand side of an equation. That was this one in this case. In this case we have 10x plus 5. If we take this 10x plus 5 is the LHS and 55 is the RHS. So RHS stands for right hand side of the equation, of an equation, right hand side. Okay, so you have to remember this. So in this case we say that LHS is equal to RHS in all of these cases. LHS is equal to RHS. LHS is x, LHS is x plus y, LHS is x plus y plus z, and so on, and RHS is 5, 3, 20, and so on and so forth. Okay, so now we have learned the difference, the left hand side and the right hand side of an equation. The next question is, what are linear equations? In these options that we have from 1 to 10, if I highlight x is equal to 5, x plus y is equal to 3, x plus y plus z is equal to 20, and then x by 3 plus 2, 10x plus 5 is equal to 55, this one, 1, 2, 3, 4 and 5. If I tell you these are linear equations, you'll ask why. Can you see here, which I have not highlighted with the star, x square is equal to 4, x square plus x plus 1 is equal to 15, x square plus y square plus z square is equal to 9, x cubed minus y cubed is equal to 10. And in this case, for a moment, just leave this one. This is very important. For a moment, just leave this one. We'll discuss this in very detail. All this, x square is equal to 4, x square plus x plus 1 is equal to 15, x square plus y square plus z square is equal to 9, x cubed minus y cubed is equal to 10. If you notice, the exponent on the variables, in this case on x we have 2, in this case we have 2, in this case on x we have 2, on y we have 2, on z we have 2, in this case we have cubed, the exponent is 3, on y we have exponent as 3. Whenever in an equation you find a variable having exponent greater than 1, then that will not be a linear equation. That will not be a linear equation. Here you can see x has the exponent 1, x has the exponent 1, y has the exponent 1, x has the exponent 1, y has 1, z has 1. Here x has the exponent 1, here x has the exponent 1. Therefore, whenever your exponent of the variables, like in this case we have only one variable, in this case we have two variables, in this case we have three variables, right? And here we have one variable, here also we have one variable. Doesn't matter whether you have one variable or two variables or three or more than that. The thing is that the exponent should be not greater than 1, should be equal to 1. That is why, let me copy this. Let me quickly copy this. Control C, V here, and then Control C and V. So these all are linear equations that we have selected out of these options here, right? So x is, sorry, this is an expression, but equations are here. So x is equal to 5 is an linear equation, x plus y is equal to 3 is a linear equation, x plus y plus z is equal to 20 is a linear equation, and x by 3 plus 2 is equal to 5 is a linear equation, and 10x plus 5 is equal to 55 is a linear equation. The thing is that the exponent of the variables should be equal to 1, right? Should be equal to 1, and if it gets greater than 1, then that is not a linear equation. Okay, now the question arises that if now we know what is the linear equation, then what is the linear equation in one variable? Very good, and that is what we want to learn. Out of these 1, 2, 3, 4, 5 options, can you tell me which all equations are having only just one variable? So you'll quickly say that x is equal to 5 has one variable, x by 3 plus 2 has one variable, and 10x plus 5 is equal to 55 has one variable. And that is what linear equation in one variable means. In these two options, that is x plus y is equal to 3, we have two variables, x and y. In this one, x plus y plus z is equal to 20, we have three variables. We have x, we have y, and we have z. Though they are linear equations, yes, they are linear equations, but they aren't linear equations in one variable. So let me quickly copy the linear equations in one variable. See here. Okay, so we have these linear equations in one variable, right? So x by 3 plus 2, 10x plus 5, and these are expressions and these are the equations. Now, if these are the linear equations in one variable and x is the left hand side, 5 is the right hand side, x plus 3 plus 2 is the left hand side and 5 is the right hand side, 10x plus 5 is the left hand side and 55 is the right hand side. So we can quickly talk about the solutions of these equations, linear equations in one variable. What do we mean by solutions? Let me take this one first from here. So if I solve this one, this is 10x plus 5 is equal to 55. If I transpose 5 from the left hand side to the right hand side, this becomes 10x is equal to 55 minus 5. This becomes 10x is equal to 50. Okay, now this is really very important. Whenever you are dealing with an equation, like if I show you here, like this is x is equal to 5. Okay, now if I add plus 1 here, then in order to maintain the equality, you'll have to add 1 here, right? Now if I divide this left hand side with 2, then in order to maintain the equality, you'll have to divide this whole with 2. Now if I make the exponent of this whole left hand side and put it squared, like x plus 1 by 2 times x, this can be written as x plus 1 by 2 times x plus 1 by 2. We have learned this thing, that what do we mean by squared and cube. If we have done this, then we'll have to do the same thing on the right hand side also in order to maintain the equality. Whatever you add, subtract, multiply, divide, or make the exponents on the left hand side, same thing we'll have to do on the right hand side. If you do on the right hand side, you'll have to do the same thing on the left hand side, right? And why this is important? Now this is 10x is equal to 50. So applying this, what we have learned here, this becomes, if we divide both the LHS and the RHS by 10, then this becomes 10x divided by 10, and this becomes 50 divided by 10. This is 10 times x. This is basically what? 10 times x, and this is what? 10 times 1. We can write it in this way. This comes as 5. If you solve it, you get x. If you solve it, you get x. And how? This can be written as 10 over 10 times x over 1 equal to 5. This gives you, this becomes 1. So this gives you x is equal to 5. Right? So x is equal to 5. This is the solution for this equation. Because at x is equal to 5, this expression, that is 10x plus 5, becomes 55. This equation stands validated or is correct for this value of x, that is x is equal to 5. Therefore we say that x is equal to 5 is the solution for this equation. Same thing here. Same thing can be done here. This is x over 3 plus 2 equal to 5. Transposing 2 on the right hand side, we get x over 3 is equal to 5 minus 2. This gives you x is over 3 by 3 is equal to 3. And then this is x. Sorry. Now you can apply either cross product, like this is what 3 over 1. So if you apply cross product, this gets multiplied with this one. So x times 1 is equal to this multiplication with 3. 3 times 3. So you get x is equal to 9. Now you can solve it in a different way also. If it was x by 3 equal to 3, then we can apply this method here, that what we have done here. If you multiply both the right hand side and the left hand side by 3, multiply, so this is x over 3 multiplied by 3, and this is 3 times 3. If you solve this left hand side, you get x and you get here 9. So one way to solve this one is through the thing that we have learned here, and another way was the cross product method. So x is equal to 9 is the solution of this equation. Why? Because at x is equal to 9, this equation stands validated or is correct for this value of x. And x equal to 5, it's already telling you that this is actually the solution is x equal to 5. Here we don't need to solve anything, right? So we have learned what? We have learned left hand side or right hand side, difference between expression and equation. Then we learned about what do we mean by linear equations. Then we learned about what do we mean by linear equations in one variable, and then about linear equations in one variable and their solutions. Now, if you remember, we said that we'll talk about this in detail. This is what x times y plus times z plus 1, and x times y times z plus 1 is equal to 5. This is an equation. Very good. Now tell me one thing. Is this a linear equation? Is this a linear equation? Now, if you remember, we said that in a linear equation, the exponent of the variables should be equal to 1. Let me copy this one here. I'm copying it here. Okay. So, we have discussed that in linear equations, the exponent should be equal to 1 and it should not be greater than 1. You will say that yes, x has the exponent 1, y has the exponent 1, z has also the exponent 1. So yes, this is a linear equations, and that is the problem. Of course, this is not the linear equations in one variable, because here we have 3 variables, but this is not a linear equation. And why? If you remember, then when we were learning about polynomials, binomials, trinomials and all, you remember in this case x plus x y z plus 1 is equal to 5 is equal to 5. This can be written as what? We can write it as x y z plus 1, or even if we don't write it, okay, let's write it, plus 1. We transpose this 5 to the left hand side, so this becomes minus 5 equal to 0. This is x y z, and plus 1 minus 5 means what? Minus 4. This is equal to 0. Okay, if you look at this equation, this is also equation that is equal to 0. We have just simplified it. If you look at this equation, on this side the expression, it is a polynomial. Now this, if you write this as x y z plus minus 4, right, equal to 0, we know that a polynomial has term or terms. In this case it is a binomial. Binomial is a polynomial. Here we have 2 terms. The first term is xyz, and the next term is minus 4. xyz is the one term, minus 4 is another term. When you will move to higher standards, when you move to higher grades, then you will learn about degree. You will learn about degree. And why I am telling you this thing is, because many of the students get confused when they think that this is a linear equation. No, this is not a linear equation. You will learn about degree of terms. Degree of terms. In this case, the degree of this term becomes 3, because x has the exponent 1, y has the exponent 1, z has the exponent 1. Therefore, the degree of this term becomes 3, right? What about this minus 4? We know that minus 4 is a constant, and for a constant this is term that is constant, and for the constant term the degree is 0. The degree is 0. And if you're wondering why, so if you remember that any number, let's say we have a number 1 or number 5, let's say we have a number 5. The question is this a polynomial? Yes, any number can be a polynomial. Why? Because we can write this as x to the power 0 of 5, x to the power 0, y to the power 0. Why? Because x to the power 0 is what? 1. Y to the power 0 is what? 1. So this is what actually? 5 times 1 times 1. This is actually 5 only. That is why we say that for the constant term, the degree of term is 0. Because here x has exponent 0, y has exponent 0. So 0 plus 0 means what? 0 only. So actually you will say that an equation is a linear equation only when the degree of the terms is actually not greater than 1. The correct definition will be that the degree of the terms should not be greater than 1. In that case, those equations will be linear equations. So then you will be wondering that whatever we have discussed here, can we relate to this one? Yes, exactly. This is what? This is x is equal to 5. I can write this as, I'm removing this. I can write this as what? X minus 5 equal to 0, because I can transpose 5 to the left hand side. Now this can be written as x plus minus 5 equal to 0, right? It has 2 terms. It has term x and it has term minus 5. Now tell me, this has the degree 0 and this has a degree 1, because it has only one variable, and that satisfies that degree of terms should not be greater than 1. It should be equal to 1 or 0 or 0. So this becomes what? This is 1 and this is 0. Condition gets satisfied. What about this one? Is this x plus y is equal to 3? So this is x plus y is equal to 3. X plus y is equal to 3. We can write this as x plus y minus 3 is equal to 0, and it can be written as x plus y plus minus 3 equal to 0. Now if you're thinking that why am I putting this minus within the bracket, so we know that terms are always positive, and we have discussed all these things in very detail. If you haven't learned all these things, I'll recommend you to go to the playlist class 7th mathematics and just check their algebraic expressions and all. We have discussed all these things in very detailed way. So this is x plus y plus minus 3 is equal to 0. This is one term, this is another term, this is another term. This is a constant term, degree is 0. The degree of this one is 1 because y has the exponent 1 and it has only one variable having exponent 1, therefore degree of this term will be 1. And same thing for here, right? Same thing for x plus y plus z is equal to 10. So x plus y plus z is equal to 20 can be written as x plus y plus z plus minus 20 is equal to 0. We have one term, two term, second term, third term and fourth term. This has a degree 0, this has the degree 1, this has the degree 1 and this has a degree 1. The terms, these terms have three terms have degree 1, but this term has degree 0. Therefore we say that yes, all these are actually linear equations because their degrees of the terms is actually equal to 1 and it's not greater than 1. But if you see here, that is x squared y squared plus z squared, the degree in this case is 2, in this case is also 2, in this case is also 2. That doesn't satisfy the condition. In this case, this is 2, here we have 1, here we have 0, but we have one term that has a degree of 2. So that is why this was our spatial discussion, because many of the students think that if we write x, y, z plus 1, then this is actually a linear equation because the exponent is actually equal to 1. And that is why I said that no, this is a special condition and it's really very important and we'll discuss in detail. So what we learned, it's actually the degree of terms that decides whether your equation is a linear equation or not. On the basis of the exponents of the terms, you decide whether that's a linear equation or not. Yes, all of these are not linear equations in one variable, but all are linear equations here.